you to take your seats, please, as we begin the afternoon session. Everyone's had a delicious lunch, and we're looking forward to a very exciting presentation so that we will stay alert. So we're looking forward to a presentation now from Abraham Shu. May I have your attention, please? Hello? Abraham Shu is Vice President and CTO, Asia Pacific for Covanta Energy Asia Pacific. He's been serving in this role since 2008. Previously, he was with Swire Sita Waste Services, and then a joint venture between, as a general manager for the Taiwan establishments. He was responsible for all aspects of the business performance, including P&L responsibilities. Since coming to Covanta in 2006, he's been leading the company's Asia business development and WTE project implementation efforts. So the topic for today is for this session is waste to energy through incineration. And today, Abraham's presentation will be on the current status and future prospect of MSW to energy in China, using Maspur and Stoker technology, with emphasis on long-term operation and maintenance. So we'd ask Abraham to come forward now, please. Let's welcome him.
Thank you, Mr. Chairman. Thank you for the introduction. My presentation this afternoon will basically give an overview of waste to energy, and then with emphasis on the plant operation and the maintenance. Now, I have prepared many slides. It cannot be possibly finished within 25 minutes. So I will selectively choose a few slides to highlight the points I want to share with all of you. Let me start with the worldwide statistics of the current solid waste management globally and as well as in Asia. Generally speaking, this data may be slightly old. It's prior to 2005, but on global basis, approximately 50% is handled by landfill and 25% by waste to energy, and the other 25% is handled by recycling, reuse, and including composting. This is the table showing that the 14 European countries, 4 Asian country and economic regions, and as well as China. And this table basically supported that the previous slide talked about 50% by landfill, 25% by incineration, and then the other methods for 25%. This is a slide showing that the 4 particular countries and the regions, including Taiwan, Singapore, Japan, and Korea. These 4 places, on average, roughly 70% is handled by incineration. Now, China itself is so big, so we separate it out. Now, this data, again, is old. It's before 2005. At that time, China's percentage by incineration is still low. But nowadays, China's the percentage by incineration is about 10%. Now, this is a quick summary of all waste to energy plants status in Asia. In Japan, there are more than 70 waste to energy plants. These are the plants greater than 300 tons per day, with the steam and electricity recovery capability. In Taiwan, there are 27 plants, and China nowadays, they have about 100 plants. That I will have the more detailed description about China later. And in South Korea, there are more than 40 plants, but only 20 plus plants are considered waste to energy plants with a power recovery capacity. And Singapore has 4 plants, and in 2005 they built a new one. Macau has 1 incineration plant, and they just have the expansion done last year. Malaysia was considered 1 gasification plant for Kuala Lumpur, but that project was stopped 2 years ago, and Hong Kong now are under serious consideration for 2 waste-to-energy plants. Thailand, there are 2 just incineration plants without energy recovery. This is the quick summary of the order that the incineration plant status in Asia. China, to give a very quick summary, there are 61 plants are in operation, where 24 plants are CFB, circulating full-time plants, and 37 are mass burn stoker plants. And there are 91 plants are under construction or in advanced development stage, which means that the relevant approval are already obtained. In these 91 plants, there are 3 CFB plants, and with remaining 88 plants are mass burn stoker plants. That means the trend in China is going away from CFB and moving to using stoker mass burn plants. Now I want to talk very briefly about a typical waste to energy plant, a life cycle event, including the first year is just simply doing the marketing, let the government and the people to know your company. Then you probably need to spend another year just to do the business development activity, including participating in proposal preparation, bidding, and contract negotiation. And after that, you need to spend 3 years roughly to build the plant, and then generally you will be able to operate the plant for 20 to 25 years. Then after that, you suppose they have 1 year to close down the plant and hand over the plant to the next operator or to the government. Now, the original I prepared to give an overview about the waste to energy plant design and the plant construction, but I think the time is too short. I'm going to skip that. You can see that all this slide that I don't think it's necessary to talk about it. A budget, all the things. Now let's talk about the plant operation and maintenance. We have heard so many presentations this morning, and I think that people now generally agree that China in the past has been very emphasized on the design and the build the plants to get the plant up running, but there has not been a lot of either regulation, government monitoring, or operational standard for waste to energy plants. So I want to spend a little bit time talk about the waste to energy plant operation and the maintenance. I think that these are very important and are going to be more important for the China's future of the waste to energy industry. Now, a typical waste to energy plant, the activity will cover the plant hangover after construction is done. Then we needed to look into that the organization and the function of all the people and their facility, daily management and operation, and there are routine maintenance repairs, there are semi-annual and annual maintenance repairs, there are major overhaul activities, and there are waste and ash sampling and analysis. And there are environmental emission monitoring things. There are health, safety, and emergency response activity. All of these activities are very important to the plant operation, long-term operation. Now, I want to give people a very, very, very generalized a plant operational cost, because this morning people talk about that the tipping fee is so low, the 20, 30 renminbi is far lower than that to have a proper plant operation. Now, in general, to operate a waste-to-energy plant without talking about the capital investment, without talking about the financing of the plant, now the two major costs related to plant operation, the highest one is the plant maintenance and the repair and the major overhaul. This should be the highest cost. And the second highest cost should be the chemical and the consumables you consume during your daily plant operation. Now, if these two costs are not the two highest cost items in the plant, then you are not operating a plant properly. Now, this is a hypothetical case without referring to a specific plant size, locations, or waste quality. But again, in very a general way of looking at the plant operation, roughly G&A probably talk about 10 renminbi per ton. Chemical and consumables probably talking about 20 renminbi per ton. Maintenance, repair, and major overhaul, we talk about 35 renminbi per ton. Salary and the utilities, probably 10 renminbi per ton. And then treat of leachate and ashes, this is probably 15 renminbi per ton. And then other costs maybe 10 renminbi per ton. These are just purely to operate the plant. Again, nothing to do with recovery of capital investment, nothing to do with development cost, and nothing to do with the financing cost. Now, a plant needed to have a proper organizational chart, which of course including the plant manager and the two major functions. One is the operational superintendent, and the other function is the maintenance superintendent. And under them they have a shift, and then on the side there are health, safety, environmental, and also on the right hand side there are plant accounting and business administration. Now, this is a overall summary of the plant operation and the maintenance, which on the top line you can see that there are different types of the needs for plant maintenance and repair, which including from the cleaning to the equipment painting to preventive maintenance, to equipment breakdown maintenance, and to that equipment system performance and improvement. On the vertical column, there are two major categories. One is that under the condition, the plant operation still can continue, and at the bottom, this is the condition that plant operation, normal operation, has to be stopped. And then you can see that under each block inside, there are many scenarios. Now, supposedly, each scenario, and you need to have a computer code, and you should have many subcategories. You give in that computer code, so you can do the proper accounting entry, tracking down of the cost, and do the analysis of the cost of the plant operation. Major item for plant operation is maintenance, repair, and chemical consumptions. Now, this is a hypothetical case. You can see for routine maintenance and repair. Now, we normally say a routine maintenance and repair for a plant is for activities you happen every year. Whether this is doing that weekly, monthly, or quarterly, semi-annually, or annually. All this called routine maintenance. You have to do this every year. You break the plant into many systems, and you do that. You can see that spread out over 25 years. Now we generate that this is the top level, and Of course, under this top level table, there are many levels, sub-levels to track that the routine maintenance, repair, activity, and the cost. And then they can do major overhaul. This is a lot of plans in China that the people have not been really going through that yet. It's major overhaul. We define that as the activity. You don't happen every year, but you happen in every 3 years cycle, every 5 years cycle. Now, again, you break the plan into many more than 100 subsystems, and you need to predict that each system at the year 3, year 5, year 7, year 9, year 10, what will happen, what you need to repair, how much do you need to replace. And you generally, you need to know your plant design, your equipment quality, and your construction quality, and your waste quality you're dealing with. Based on all this information, and you make it a 25 years prediction of which part, which equipment, which system, what do you need to do at which year. That's called major overhaul. And that usually an experienced waste-to-energy company, they can do that at the very beginning before the plant construction will start. Okay, and you can see that the table continue going into many systems. Now I want to talk about the chemical and consumables. For this is the second largest cost item for plant operation maintenance. For plant operation, again, this is the area that a lot of plants in China, they have been not fully, or I would say that properly handled. There are many chemical consumables that need to be consumed in the plant to maintain the plant daily operation properly. They are lime, and they are for removing HCl and the SOx. They are cement required for fly ash solidification. They are chemical chelate needed for trapping heavy metals. They are activated carbons needed for trapping dioxin and heavy metals. The river water in general are used for cooling tower water evaporation, and city water are for kitchen, toilet, office, and washing. And diesel fuel are for startup and stabilize combustion. And sodium phosphate, hydrochloric acid, and sodium hydroxide. All these three chemicals are for the boiler feed water treatment. And then you need a chemical detergent to wash the plank and the tipping floor, and you need the anti-sludging chemical for keeping the cooling tower clean. These are the chemicals. The major costs are for the top 4 items: lime, cement, chelate, and activated carbon. These generally represent more than 70% of the chemical cost for your daily operation. Now you can see that we normally we calculate that for each ton of waste how much chemical you need. And we also calculate that based on different environmental emission regulation, whether based on China's GB standard, based on EU 2000 standard, based on the hybrid China and the EU mixed standard. And for different standard implies a different chemical you need to operate the plant in order to meet the emission requirement. Now this again is something that a experienced waste-to-energy company will do that, but a lot of times that are not well addressed in China. Now there's another big thing is performance test. Performance test again is another thing that most waste-to-energy plant in China has not done that properly. The typical so-called performance test in China is just 7 days plus 24 hours turbine synchronization test. But these are not the waste-to-energy plant performance tests. A truly waste-to-energy plant performance test, including the environmental performance test, energy efficiency test, the throughput, which both waste and the thermal throughput performance test. You involved with the boiler calorimetry calibration and calculation for waste heating value. And there's a residual bottom edge and fly edge quality analysis. That's also part of performance test. And also you need to test the utility consumption performance for the in-plant power usage, for potable water usage, for wastewater discharge, and for effluent and auxiliary fuel consumption. That's also part of the performance test. And then they also needed to test for reagent consumption, for urea, for lime, for activated carbon, for cement, for chelate. Now all these tests has to be done under different conditions. At 70% of the plant capacity, at 100% of the plant capacity, at 110% of plant capacity, and has to be done when boiler is clean or when boiler is falling, already operate after 30 days. So you are measuring this thermal efficiency when boiler tubes already formed. Okay, these are called real complete performance test. And also that the full performance test, your instrument need to be calibrated. Everything, temperature, pressure, flow meter, continuous emission monitoring system, and need to be properly calibrated within 30 days before the performance test. And then all the chemicals and the spent gas and the reference material you use for the performance test need to be verified for the specification match up with the EPCO design company's qualification. Your data need to be recorded, analyzed, needed to define proper calculation, and especially for the waste heating value. Generally speaking, people do not rely on the grab sample to do that heating value measurement. And you do not use bomb calorimeter to measure that. People use the boiler code, which is ASME boiler PDC code 4 or the new one 31. Okay, and then data acquisition system that need to be properly installed. And this is just that I'm just showing the different standards between EU, between United States, and between China, and I don't think that we need to go into that detail. But in general, that the EU are most stringent, US almost the same, and Chinese the various emission standards are more relaxed, but quickly catching up close to EU standard. And bottom edge and fly ash treatment, I want to show that for a fly ash treatment, you will see that a standard way to treat the fly ash is you have fly ash, you have cement, then you have a chelate, all go into the blending machine, and then come out and put it in the bag, curing for 72 hours, and then you go through the TCLP test. If you pass, you can send it to landfill. If you do not pass, you have to send it back and go through the process again. Now, this is a fly ash blending machine, what it looks like. This is the fly ash blending machine. And this is a chelate tank, which use the chemical used to trap the heavy metals. Okay. This is the bottom edge recycling and the reuse system, which goes through the sorting, magnetic separation, eddy current to separate out the non-ferrous metals, and goes through that a gravity separation. And that's the bottom edge recycling system looks like. Now, in terms of cost to operate waste-to-energy plant, I am going to skip because there are way too much details. I'm not going to show that. But in general, you want to track that the cost item up to several thousand items in the plant, given the proper accounting entry numbers, computer code, so you can properly track, analyze, and then you can compare the actual versus budget. Then I want to talk about this the last topic about the key issues of waste to energy in China. One thing I wanted to highlight is waste to energy plant is a waste management facility. It's not the power production facility. So there are differences. Now the detail I will not talk about here. In general, China's tipping fee is way too low. A lot of people talked this morning already. And there are many companies just wanted to win the project rather than taking a long-term view to operate and maintain the plant properly. And there's no true performance in China yet. Both the government, private industry, and the consulting companies now are very emphasized on the design-build plan, and there are very little attention or thought going into long-term operation and maintenance. And in terms of public tenders, that we think a lot of terms and conditions are not workable because tipping fee is too low versus the one that to have import equipment. Tipping fee is too low in terms of wanted to meet the stringent environmental emissions standards, both for ash and for air. And there's another problem I see in China. There's no floor pricing mechanisms. We see in many tenders the requirement is to limit you the ceiling price. You cannot bid for a tipping fee above a certain price, or you use the average price. But there's missing of a floor pricing mechanism. I believe one of the speakers this morning talked about that's a problem. Yes, I agree. In many international tenders, people do specify you cannot bid below certain price. If you bid below certain price, they will require you to post a differential bond. If you want, yes. If the floor price is 700 million, you bid the 500 million. Fine. If you guarantee you can do it, it's fine. But please post 200 million differential bond. Government will keep it until you finish your contract. They will return it to you. And I think that's this is what my presentation. I think that for a short-term period, China's market will remain like that with the issue I talked about, but the market will self-correct. In a few years, it will go back to normal. That's my presentation. Thank you very much.
Okay, Mr. Shu, we have time for one question.